Does day two. Okay. So again, we're studying very limited perspective of vectors in calculus, just motion along a curve. There's a lot more to it, but we're not getting into that. So let's look at one example. Has 4 parts. I'll let you work on your homework. We'll be done. Okay? Yeah, pretty easy day for us. An object moving along a curve in the xy plane has position x of t, y of t at time t, with dx dt equals sine t cubed. dy dt is cosine t squared. At time t equals 2, the object is at position 1, 4. Okay. What we can also say this is velocity, right? So keep in mind the derivative is velocity. Now, finding the acceleration vector at time 2. We can do that from yesterday, right?
Yeah.
So, what's the derivative of sine t cubed? Dx.
This should be cosine.
Cosine should be cosine. You're right, I'm saying it's easy. This is why I don't get hundreds on any test ever. They don't pay attention. So that is the acceleration vector. Feel free to note it as such. And then A of 2 is plug it in. And this is calculator friendly because we don't have a unit circle value to evaluate that. I got make sure you're in radians mode again because my pre-calc kids were in degrees earlier. Okay. Good. Part B. Write the equation of the tangent line to the curve at t equals 2. This is where you have to remember your parametric. Remember, dy dx is dy dt over dx dt, okay, which we're already given, thankfully, right? So and then evaluate it in 2. That gives us our slope.
Mr. Arthur, isn't it dy over dy dx?
Can I write it backwards? Just kidding. Pay attention.
Oh, yeah.
Yeah, watch me. Apparently I'm tired. Y's over x's. Let's do slope properly, right, Algebra 1? If you evaluate those at t equals 2, you get cosine 4 over sine 8, which is negative 0.661. There's our slope, right? And then what's our point at t equals 2? 1, 4. So it's just given to you. They could say, not give this to you, but you wouldn't be able to generate it because you have to have an initial condition to calculate the values here. So that we just gave it to you. So y minus 4 equals negative 0.661 x minus 1. Equation of tangent. Speed. And again, I always suggest writing these down so they're, they stick in your brain better. Okay. So What is dx dt squared? At 2, right? Sine t cubed squared.
Sine squared t.
We do want to plug 2 in, right? And then you get your answer. Are there units on this? No. Okay.
I didn't get
What'd you get?
1.00.
Well,
Check your mode.
what did you say?
Make sure you put these in parentheses.
What was it? Let's calculate what's usually.
Okay, this is the one I really want to focus on, position of the particle at time 1. We're given the derivatives, right? How do we get back to position? Yeah, great. But when we have to have our initial condition, we have to consider, remember that, right? So at time 2, we're at 1, 4. Note that. We're asking for time 1. We're actually going backwards. Okay, so there are 2 ways you can think about this one. Okay, the x starts at 1, right? Plus the integral from 2 to 1. Right? So we can add going backwards. Or we can do 1 minus the integral from 1 to 2. Okay. It doesn't matter. The way it works is the same thing. That's on your AP Calc test, you're gonna need to write this stuff down because they give a point for this, maybe 2 cents.
That be section 2.
Oh, sorry, this should be B. No, that's X right.
No, on the left, where it says X of T equals all that, should be X of T instead.
Just use that would be. No, it's X of 1, sorry.
Oh.
Yeah, equal one. So that's for people watching this video. Yeah, we're looking for time 1 position. This is X of 1. So if you throw that in your calculator, remember this is sine t cubed, right? You come up with 0.78. That's your x coordinate at time 1. The y is the same. Or knowledge rate.
Oh, yeah.
We're good here? Okay, then the y, right? It's the same process. 4 minus the integral from 1 to 2. That's y prime of t. And we get 4.44. And don't forget to write your final answer of the position at time 1. Remind us around the fundamental thermal calculus and initial conditions. Any questions? Okay. Sounds good. That's all I got. We're done. Yay, man, South of Joy. You guys are so excited. Okay, you still have a test this week. Just some pressure there. Your homework is on the back side.